Hey there, Brian Davis, Home Improved Man. I got another tutorial for you today. We're going to be replacing an outlet. So I have a new outlet here, and a lot of the modern outlets are tamper resistant. It is not absolutely necessary. It is highly recommended. Keeps little ones from sticking things like screwdrivers and things into the slots, so look for the TR on them for the tamper resistant. Now, a couple reasons why you might decide to change out your outlets. One, you want a different color. Another reason is that one has been damaged. If you look at this outlet, you can see a fair amount of damage. In fact, the faceplate is missing. I think it's here. So this is what it used to look like and no longer does. So yeah, as you can see, we got a safety issue, so we're going to change it out. Electricity is worrisome for a lot of people, and rightfully so. It's unpleasant to get the shock from one of these things. So before if you are planning on doing any sort of electrical work, I do highly recommend one of these devices. Tells you when the circuit is live. It's important to understand that you'll only get that signal where the current runs through. So usually in US households, the black wire. If you go to the other side, to the white wire, you will not get any sort of signal. So always want to check all the wires to see if there's a live wire inside the box or anything you're working on. Turning it off. There we go. Another one that can be useful if you're working particularly with outlets is one of these devices. Now, these are useful not just to show power, but they can show you if the circuit is wired correctly and if there's a mistake, what the mistake is. So by plugging it in, finding where the circuit actually was, you look on top, you see the light to show that there's power, but then you'll also see that you have two amber lights and that the red light is not lit. And then if we check the guide on the back, that tells us that wiring is correct. Other options would be one amber light, the middle amber light, which means there's an open ground, the far amber light meaning an open neutral, and so on. So these are useful. One of the reasons why they're useful, not just because it can give you more information, but we need to now go and turn off the power to the circuit here. And so what I can do is plug this in and walk away, go and find the breaker, and then all I have to do is stick my head in the doorway to see if the lights are lit or not. With this device, I would have to come all the way to the outlet, turn it on, touch the outlet, see if it's still live, and then go back again. So this allows us a little bit more, I don't have to walk quite as far in order to see if the outlet has been shut or if the circuit's been shut off or not. So let's go find the circuit breaker. Here we are at the circuit breaker. Now, if you're lucky, you'll find a tag on the breaker someplace that says outlet for the blue bedroom. But most of the time, you're not going to find that. So there's a little bit of deciphering that might have to happen. As you go through, a couple of things that you can eliminate. If the bar spans across two of the breakers, that means that the breaker has double the voltage, 220, and that's usually reserved for things like heaters, electric stoves, big heavy pieces of equipment. So it's most likely not going to be an outlet or a light if it has that setup. So you can start off eliminating those. Also, there are certain pieces of equipment that you almost always get their dedicated outlet. They're only for that object, such as a dishwasher. Oftentimes, if you have the older microwaves, they would get their own outlets. Washers and dryers are usually on their own, I'm sorry, not outlets, but their own circuits. And so what you're looking for oftentimes is something like first floor outlets or bedroom outlets or something like that. If you don't find any of those, you're just hitting outlets, taking a walk back, looking to see if the lights are still lit on your breaker, or I'm sorry, on your tester, and then coming back, turning that one on and trying a different one. So I can tell you that this one is illegible. There's a piece of masking tape, there's some words on it, I have no idea what the words say, but this is the breaker that I want to turn off. And when we go back in, you'll see now that the tester has indicated that the circuit is no longer live. As you can see, the circuit is no longer live. To verify, I can pull out my audio tester. Okay, so we just got one little beep, which can sometimes worry somebody. But if you don't have that long sustained tone, there was just a little bit of voltage that was maybe stuck inside the circuit. Or, as you can see now, the circuit's dead. Check both sides to make sure. Yeah, we're good. Now we can disassemble the circuit. It doesn't normally come apart like this. This is not typical. Now, if you look at this, you'll see we have two black wires on one side and then two white wires on the other. And so when you have the two wires like that, what that tells you is you have the power coming in on one pair, black and white pair, and then going out on another black and white pair to another outlet or to some other place in the house. It might be coming from the breaker box, it might be coming from another outlet, but a pair of wires coming in, a pair of wires going back out. That's the important part. If you have just a single black and white wire, that means that that receptacle or outlet or whatever you're working with is the end of the line. It might be the only outlet on the circuit, or it could be the last outlet. It doesn't matter. So you'll have either one or both pairs of wires. This particular outlet has the wires that it has is, if you look back here, the wires are stuck, not wrapped around the screws, but stuck in the holes in the back. A little more difficult to get those out in a normal situation where you actually had an outlet with a face on it. In this case, it's a little bit easier, but you can still disassemble it. Now, if you are the cautious type, nervous, feel free, test it again. Make sure, what if I didn't hit the right wire? Remembering that you usually want to test the black wires, and now I can see the black wires, and so I can test it again, touching specifically each of the black wires to ensure that there's no power there. There is no power there, so I can move on. Now, normally in this setup, in order to remove the wire, if you look closely here, you'll see up top, there's a little slot or a hole, and pushing down into that will release the pressure on the wire. Now I'm betting, because I have access from this side, which is not typical, I can see actually how it's held in place, and I can probably remove it a little bit more easily from the front side as well. So using simply a nail or a screw or something similar, I can pull that wire out. If you have a small screwdriver, it's a little bit easier than using an old nail, but this will work. All right, so this just came off. This is what it looks like on the inside. And as you can see, it's simply just a piece of metal with a couple screws to attach wires. And so it doesn't matter whether the source of the electricity is on top or the bottom, it connects. The whole thing is connected. What's important is that on each side you have the two black wires connected, because they're not connected to the other. Let me show you on this one. So the black wires go on one side, the white wires go on the other, because they're connected and they're bridged across the screws. So black to black white to white. The standard is that the modern outlet is color-coded. And so the way that I remember is that one of the screws looks closer to white, and so that's where the white screws go. And there is one other screw on this, you'll notice, and that's the one down on the bottom, the green screw. Now here we have the same thing. They're usually green, but if you have an older outlet, it might not be green. That's where the ground goes. The ground is either a green coated wire or a bare copper wire. Now remember that in older homes, they may not have a ground. You cannot put a ground wire in an outlet that doesn't have a ground wire. Throwing a copper wire in there won't do you any good. So if it doesn't exist, you can't throw it in there unless you have... This is just going to fight me the whole way, isn't it? There we go. The only time you can add a ground where there isn't one is when you have metal boxes and metal coated wires. But it needs to be, a ground needs to be attached at the other end, down by the circuit breaker. And that has to be done by an electrician. So in most cases, if there isn't a ground wire, nothing you can do about it. And that comes up into play with this little sensor as well. If you get the light that says no ground, but there's no ground wire in there, there's nothing you can do about it. It's just old wiring, other than rewiring the entire house. So now, you can either wrap the screws with the wire or utilize the hole that's at the back here. A lot of electricians will tell you that the holes can fail, that sticking the wire inside the holes is not as effective as wrapping the screws. They may be correct. I don't know. I still stick the wires into the holes. Now the hole is designed for a 14 gauge wire, the smallest wire that you'll typically find in the house. So if you have a thicker wire, because you've got more draw on that circuit, or if you have someone decided to be a little more robust and future-proof your home, then you won't be able to stick the wire into that little hole in back. You'll have to wrap it around the screw, unless, of course, you have an outlet that is designed for it. Now you want to get the wire as deep, as close to the outlet as possible, so there's very little exposed wire. That way there's little chance hopefully, of wires touching, of coming loose, of shorting the circuit, and so make sure that that's the case. Now the last thing we have to do is to attach the ground. Okay, so we got the green wire over here, and we have the ground. Unfortunately, they kept the wires very short, not that easy to work with, but I think we can make it work. We're going to wrap, because you have to wrap on the ground, or you can stick it behind the plate. That's for a different video. Pull it in tight. And lastly, make sure that it is really, the screw is tightened down onto the wire. Oops, wrong way. Lastly, we put the wire back into the outlet box, remembering the circuit's dead. But if you want to test it again, because you are sticking your fingers onto those wires. You have the two screws at the top and the bottom. You have the holes on the back of the box, up here and down below, and that is where we will be attaching it. Now, old outlets and switches used the flathead screws. Modern use the Phillips head. Phillips is easier. So even though I can fit a Phillips bit onto that screw, I can't fit a flathead bit onto that screw. I'm going to switch to the Phillips because it'll seat better, it'll hold in place better, and I'm more effective as I put it into place. Now, I want to be a little bit even. I want to make sure that the outlet is moving evenly towards the wall, rather than tightening one screw, the top for example, tight to the wall, having the bottom flared way out, and then having to push that one in because it can unseat the wires, it can create other issues. So I want to make sure that the outlet is pretty much where I want it, and then a couple turns top to bottom, going back and forth. Now, where you stop is where this flange that sits out gets snug up against the wall. So the bottom's not moving, the top still moves a little bit, so I want that to be a little bit tighter. I don't want to over tighten it, where I start to bend that flange and set the outlet too deep, too far into the wall. Take the plastic tape off. And then before I put the cover onto this outlet, I'm going to test it one more time. Be right back. So, power. And even better, as you can see, I get the light indicators that tell me that it is wired correctly. And of course, I can verify with my tone tester. We have a live circuit. So then you can go ahead and put the faceplate on and you are done. I hope you found this video helpful, and feel free to like the video, subscribe to the channel where you'll have lots of other interesting, exciting, informative, possibly educational videos that you can peruse at your leisure. Thanks.